Alrighty, so we are about to take our first 9 weeks test. So we are going to do a review. Okay, so I'm going to go through at least one of every problem for this, especially the algebra review, just to kind of help y'all, but then giving you an example to kind of help yourself out. But let's get started. Okay, alrighty. So here we want to solve for y. We want to solve for y. So what we're trying to do is get y by itself. Okay, so I'm going to subtract this 2x. Now, the reason why I'm subtracting the 2x is because I want to get it to the right side. But if I subtract my 2x, I can't necessarily subtract it from the 16. So I'm just going to just keep it over there. So I'm left with, on the left-hand side, 4y equals negative 16 minus 2x. Well, then my next step would be to divide by 4, because then I'll finally be able to get rid of the 4 paired with the y. That's multiplying to the y. So I'm left with y equals on the left-hand side. But when you're dividing, and there's multiple things that you're dividing with, you have to divide everything. So you have to take negative 16 and divide it by 4, which we get a negative 4, and then a negative 2x divided by 4, which gets you a negative 1/2 x. And then that's our answer. Okay. All right, so there's two ways we can find the slope of the line. We can either try to graph this, or we're just going to use the point slope formula. So when we're trying to find slope when giving 2 points, we're going to do y2 minus y1 divided by x2 minus x1. Okay, so then we just come over here and we're going to label our points. And we just plug in. So y2 is 15. y1 is 10 divided by x2, which is 6, subtracting x1, which is negative 5. So 15 minus 10 is 5, and then 6 minus a negative 5 is 11. So our slope of this line is 5/11. Now, you will have a question like this on your test. You will. Okay? All right, so I'm going to do this one, okay? I'm going to, and I think on your review it's like this, but I could be wrong. But if it's not, go ahead and mark out that x with it, because that's going to turn into a quadratic, and we don't need to talk about quadratics, okay? So we're going to try and solve for x here, but there's a lot going on. So I'm going to start with the left-hand side, and notice that there are parentheses. Okay, well, I have to distribute what's on the outside of those parentheses first, so I have to expand the equation. So 10 times x, which gets us 10x. 10 times 3, which is 30, so add 30. Now, there's this negative sign right here. You have to pretend this is a negative 1. So negative 1 times a negative 9, which gets us a positive 9x. And a negative 1 times a negative 4, which gets us a positive 4. And then equal to x minus 5 plus 3. My next step, I don't like when that thing goes away. My next step is to combine like terms. So I have a 10x and a 9x, which gets us 19x. We have a 30 and a 4, which gets us a positive 34. We don't have to combine anything on the right side with the x's, but we do have a negative 5 and a positive 3, which gets us negative 2. Okay, now we can set our railroad tracks and move things from left to right. So I'm going to move my x's like I always do. Doesn't necessarily have to be the first step, but it is what we're solving for, so I want to make sure I keep my x's positive. So I'm going to subtract my x. Well, 19x minus x, excuse me, is 18x plus 34 equals -2. Now we're going to subtract 34 because I want to get rid of it. So now I'm left with 18x on this side equals -36. And then last but not least, always, always, always divide by your coefficient. So x should equal -2. Okay. All right, points, lines, and planes. So here's how it goes. I want you to find the definition. So you're going to match the definition. So a point is a location. So that's F. Okay, exact location in space with an indefinite shape and size. So this is F. Okay, and then I want you to come to this picture right here on the right-hand side, and I want you to just choose an example. So literally anything. So like point F is 1. Point B is also 1. Point A is also 1. It doesn't matter. All of those are points. Okay? All right, a line. A line is something that goes and extends forever and ever in both directions. So an object with no thickness that extends infinitely in 2 directions. So a line is H. Okay? And then here you're going to try and find which line goes on forever and ever. Okay, and you should notice that it's line CE because they have the arrows. So it should be line CE, and then remember you always put the lines with arrows on top. Okay, so a line segment is a part of a line consisting of 2 endpoints and all the points in between. Then I want you, so remember a line segment, if we put 2 fists out and we extend our hands out like we're a cheerleader, that is a line segment, okay? It doesn't go on forever and ever. So an example here would be line AB. All right, array. Array is a part of a line that's consisting of 1 endpoint and extending infinitely in 1 direction, RIP. So that is B. So like DE is array. But so is DC, okay? It starts at point D. It starts at point D and it goes through point E. Okay. Opposite rays are pretty much, it's rays that share a common endpoint but continue infinitely in opposite directions. So C. So it would start with DE because DE is a ray, but then we need another ray that starts at point D, which in this case it's ray DC. All right, a plane is a flat surface that continues infinitely in all directions. So like plane M here. Collinear, so collinear are points that are on the same line. Points that on the same line, that was the same plane, so A. And I want you to determine what the examples are. Non-collinear are points that do not lie on the same line. So J. Coplanar, E. Points that lie on the same plane. And then so non-coplanar would be points that do not lie on the same plane. Okay. Find examples for these. All right, remember the intersection of 2 planes is always a line. So if I have plane GFE, so this plane right here, and then my next plane is AFD, so this one. So pretty much I'm looking for a line that touches both the blue and the red side, which in this case is FG. So in which line do they both intersect? And it's this line right here. Okay, so I want you to try to find the other one. Remember, it's always a line for a plane. All right, distance and midpoint. So I plotted the points for you already, but distance formula is under the distance word and midpoint formula is under the midpoint word. So I want to find distance here. I want to find midpoint. Okay. And 3 is a little bit different. So remember, if I want to find the length of S between ST, I have x1, y1, x2, and y2. And then midpoint for UV, so I have x1, y1, x2, y2. Remember, I'm looking for coordinates here. This isn't the answer. I want you to actually solve it. I'm looking for coordinates here. And here, I'm looking for a positive number. Okay? If you plug it into this formula right here, okay, you could put it in your calculator all at once as long as you put the parentheses, and it should spit out your number. Let's do number 3, though. Okay? Number 3 says, given that R is the midpoint, so we're looking at this segment right here. Given that R is the midpoint of the segment OZ, what is the coordinates of Z? So we're looking for midpoint. Okay, so we could use the algebraic way to solve that, or we're looking for endpoint. So I'm looking for endpoint here. We could use the algebraic way, because we have a graph, let's just find it graphically. So let's just remember how we find it graphically. We find the slope between the 2 points. So 1, 2, 3, 4, 5, 6. So I go down 6, and I go to the right 1, 2, 3. And then I repeat. So I'm going to go down 6. And then go to the right 3. And there's point Z. And then from the coordinate or origin, I would just find what it is. So it's 1, 2, 3, 4, 5. So it's 5, -8. Okay. All right, angles. We literally just took a test over this. So angles that measure less than 90, acute. Two non-adjacent angles formed by intersecting lines, they will always be congruent. Vertical angles. Array that divides an angle into 2 congruent halves, angle bisector. Two angles that have a sum of 180 degrees, so this is supplementary. Okay. Name the vertex. Should be M. Name angle 1 another way, so it's talking about this angle right here. You can't label it as just angle M. Hint, hint. And then I want you to classify angle NML. I want you to classify it. All right. What type of angle pair are the labeled angles? So this should be a vertical pair. And how you solve it, it says find the measure of angle 1. So it wants this angle right here. Well, they're vertical, so they're always congruent. Okay, so we have 4x plus 4 equals 8x minus 8. And that's how you solve that one. All right, find the value of x. This is a linear pair. So you're going to do 3x plus 12 plus 2x plus 8 equals 180. Okay, sorry, it wouldn't let me. Here we have this little box right here. So this is a complementary pair, so they add up to 90. So you have 2x minus 3 plus 3x minus 2 equals 90 degrees. All right, last part of it all. I want you to name the polygons, okay? Talked about all of them, starting with triangle, remember? Hopefully that'll help you. And if you don't remember, you can always look it up. Okay, find the sum of the interior angles. You're going to use n minus 2 times 180. Remember, it's the sum of interiors of an undecagon. So when you find what these are, you can use this to be able to solve these problems. Find the measure of each interior angle. So it's the same thing, n minus 2 times 180, but it's going to take one step further and divide by the number of sides. The sum of the measure of the exterior angles are always 360. I gave you an answer. And then find the measure of each exterior. Each exterior, you're going to take 360 and divide it by n, divided by the number of sides. So if it's a quadrilateral, you're dividing it by 4. Okay, I hope this helps, and good luck. Y'all are going to rock it.